Hey everyone, I'm Kizai and welcome to the tutorial channel. So today we're going to discuss about CNF and DNF. First, we're going to discuss about CNF, Conjunctive Normal Form, which is a common proposition that can be expressed as product of sums. So consider the examples. P or Q or R and P or R and R is an example of product of sums because we are using the and sign. Then we have another example, not P or Q or not R. Then we have and P or Q and not R. Okay, taking the sign as a multiplication and or as an addition, we have P corresponds to 1, false corresponds to 0. If P is true, then the negation of P is false. So consider the examples. We have the statement P or not Q or R is false if and only if P is false and Q is true, which means not Q is false, and we have R is false. Then another example, we have not P or not Q or not R is false if and only if P is true, which means not P is false. Q is true, which means not Q is false. And we have R is true, which means not R is false. Then we have not P or Q or R is false if and only if P is true, which means not P is false. Q is false, which means Q on this side is false and R is false. Consider the question that we have been given there. So this says express P and Q in conjunctive normal form. So the first thing you need to do when you ask such question, you need to construct the truth table for P and Q. And here we have the truth in the last column. We have true, we have false, and false. So in CNF, you consider the tables that have false value. It has a false value. It has a false value. So this statement means not P is false and Q is false, which means the statement P and Q is false. Then we have P or not Q is false if and only if P itself is false, which means P is false, and not Q is false, which means Q is true. And we have P and or Q is false if and only if Q is false, sorry, P is false and Q is false. So the solution will come and write P and Q is the same as, and use this sign, not P or Q and P or not Q and P or Q, and there you have the solution. Consider the next question. Express P implies Q and Q implies R in conjunctive normal form CNF. So the first thing you need to do, as we have said earlier, construct the truth table for the expression. Okay, when we are writing a statement in CNF, so as you can remember, we have said that consider the rows that have false value the false value, the false value, and the false value. So this statement, the first one, we have not P or not Q or R, which means P is true, Q is true, and R is false. As you can see here, we have P is true, Q is true, and R is false. Then the next one, we have not P or Q or not R, which means P is true, Q is false, and R is true, which means not R is false. We have not P or Q or R, which means P is true, not P is false, Q is false, and R is false. As you can see here, we have P is true, Q is false, and R is false. So in order for P or Q or R to be false, then we have to negate P. So this statement comes here, we have not P or Q or R. Then the last one we have P or not Q or R, which means P is false and P is false here. Then not Q is false, which means Q is true and R is false here. And we have this one. So the solution you write, obviously you write these statements here. Then as you can see, they are in form of sum terms. They are in form of sum terms. So in order for you to write in CNF, then you combine them with a multiplication sign, which is an AND. So we have not P or not Q or R, and not P or Q or not R, and we have not P or Q or R, and P or not Q or R. So next, let's discuss about DNF, disjunctive normal form. Refer to a compound proposition that can be expressed as sum of product. And consider the example. We have this this expression here is an example of sum of product. As you can see, the literals Q and R, or P and Q and R, or R. Then we have P and not Q and R, or not P and Q and R, or Q. So taking this sign as a multiplication that we are ANDing, we use AND. Then we have this one as an addition, the OR sign. True corresponds to 1 and false corresponds to 0. If P is true, then the negation of P, not P, is false. Then this statement, not P and not Q and R, is true if and only if P is false, which means not P is true. We have Q is false, which means not Q is true, and we have R is true. Then we have P and Q and R is true if and only if P itself is true, Q is true, and R is true. So let's look at question 3. Express P implies Q in DNF. So the first thing you need to do, construct the truth table for the expression. And here we come. We have P implies Q. So for DNF, consider the rows that have truth value. So we have this column, this row, and this row, and this row. So this row, we have this statement here: P and Q is true if and only if Q P is true and Q is true. And this statement is true if and only if P is false, which means not P is true, and Q is true, which means here it is we have true. So this one, not P and not Q is true if and only if P is false and Q is false. So the solution will come and write P and Q, or not P and Q, or not P and not Q. There you have your DNF. Let's consider the another example. Express P implies Q and Q implies R in disjunctive normal form DNF. So here we construct the truth table. Then we have this row with the truth value, the row with the truth value, the row with the truth value, and the row with truth value. So these statements, you come and write the statements here. P and Q and R is true if and only if P is true, Q is true, and R is true. Then we have not P and Q and R is true if and only if, here we come here and say P is false, which means not P is true. Then we have Q is true and R is true. Here Q is true and R is true. Then we have this statement: not P and not Q and R is true if and only if P is false and Q is false and R itself is true. Here P is true, P is false, Q is false, and R is true. Then we have the last statement. In the last row, we have not P and not Q and not R is true if and only if P is true, Q is false, and R is false. And there you have the solution. This expression is the solution in DNF.